Hello, I'm Martin Warren and I'm going to give a short presentation on rounding numbers to a number of decimal places. The objectives of the presentation are to discuss how to round a decimal number to a stated level of decimal places, or how to round a decimal number to a stated level of significant figures. They both employ the same technique. Decimal places. Here we have a number, 35.986 kilometres. So first of all, we have to understand what the various numbers mean in this case. So the 3 represents 30 kilometres, the 5 just represents 5 kilometres. We then go across the decimal point, 0.9, that's 9/10 of a kilometre, or 900 metres. The 8 represents 800ths, or 80 metres. And the 6 represents 6,000ths of a kilometre, or 6 metres. So this number is expressed to 3 decimal places. In other words, its accuracy is down to metres. So with thousandths of a kilometre down to 1 metre. Rounding to 3 decimal places. So we're going to start counting from the first digit after the decimal point. We're going to count 3 decimal places, and then we're going to change that decimal place, the third decimal place, depending on the value of the fourth, or we're going to leave it alone. If the value of the fourth decimal place is less than 5, in other words 0, 1, 2, 3 or 4, we leave the third decimal place unchanged. If the fourth decimal place is 5 or greater, 5, 6, 7, 8, 9, we round up the third decimal place. So just to go over that, if the final digit is 5, 6, 7, 8 or 9, we round up the preceding decimal. If the decimal place is 4, 3, 2, 1 or 0, we leave the preceding decimal unchanged. Just to go over a couple of examples, here we have 0.562. and we wish to round that to 3 decimal places. So we start counting from the decimal point, 1, 2, 3. So the 6 is the third decimal place. We then go one stage further, look at the fourth decimal place. It's a 2. Is that less than a 5 or greater than a 5? Well, it's less than 5. So when rounding to 3 decimal places, we leave the third digit alone and it becomes 0.456. Here's another number, 32.0917. We're going to round to 3 decimal places. Look at the third decimal place, it's a 1. What comes after it is a 7. Is that greater than 5? Yes, it is. Therefore, when rounded to 3 decimal places, that third decimal place is rounded up to a 2. 32.092. Another example, 25.1299. Third decimal place is that first 9, the fourth decimal place is the second 9. Is that greater than 5? Yes, it is. Therefore, we're going to round it up to a 0. It means we carry out 1 forward, and we end up with 25.130. So we rounded up the third decimal point 9 to a 0, but we had to carry the 1 forward. And note, you have to write 25.130 and not 25.13. because that shows you've rounded to 3 decimal places, not 2. Significant figures. Rounding to 3 significant figures. Again, exactly the same process as before in terms of rounding up or down, but in this case, because we're rounding significant figures rather than decimals, we start counting from the first non-zero digit, regardless of the position of the decimal point. And then we make the same decision we had before. If we're going to round to 3 significant figures, we look at the third digit and change it accordingly to the value of the fourth. So if the fourth digit is less than 5, leave the third unchanged. If the fourth digit is 5 or greater, round up the third digit. We wish to round this number to 3 significant figures. It's 5.4162. So we start counting from the first non-zero digit, which is 5. The third digit is a 1. The fourth digit is a 6. Is 6 greater than 5? Yes, it is. Therefore, when we round that to 3 significant figures, it becomes 5.42. And in this case, that's same as rounding to 2 decimal places. Another example, 0.003495. We wish to round to 3 significant figures. So again, we're going to start counting from the first non-zero digit, which in this case will be a 3. So 3, 4, 9 is the third figure. 2 is the fourth figure. We apply our rule to that. Is it less than 5? Yes, it is. Therefore, we do not change the third. So we round down to 0.00349, which in this case corresponds to rounding to 5 decimal places. Here we have 54,634, which we wish to round to 3 significant figures. So again, we start counting from the first non-zero digit, which in this case is 5. 5, 4, 6 is the third figure, 3 is the fourth. We apply our rule to that particular figure. It's less than 5, so we round down to 546, but we don't write 546. We have to remember that it's put the zeros back. So it's 54600, 54,600. If you wrote 540, you produce a number which is far, far smaller than the original one. Another number, 25,682,424. We wish to round to 3 significant figures, exactly the same as before. Find the third figure, 256, that's the third figure. Look at the fourth, it's an 8, therefore we round up. So 257, put all the zeros back for the ones we've dropped, 257,000,000, or 25,700,000. Why round to so many decimal places or significant figures? Well, the reason is that it makes the numbers easier to work with. In that last example, we had 257,000,000. That's easier to work with than 25,682,424. We kept the significant digits, 25,700,000, and lost some of the smaller digits, 424 for instance, because they're less important. So in summary, we rounded a number in normal format to a certain level of decimal places, and we did the same for a number in normal format and rounded it to a stated level of significant figures. The actual rounding process is the same in both cases. You look at the digit you're going to round to, you look at the next one along. If it's 5 and above, you round it up. If it's 4 and below, you leave it unchanged. Thank you very much.